All right, hello there. So we're going to talk about exponential functions today. And there's the picture in honor of voting day yesterday, or whenever you're watching this. All right, so here we go. So exponential functions. Now, this was something in Algebra 2 last year that you might have done in a little shorter of a way because of the quarantine and whatnot, but you did cover it, assuming you were participating in your learning last spring. But anyway, we'll just be sure to cover it fully here. So let's go over some of the things that you've already done. For instance, absolute value. When we've talked about absolute value functions this year already. Absolute value looks like that. Remember, when you look at the graph, you have a V-shaped graph, right? So these are your basic functions you've done. Quadratic. There's, y equals x squared. That's the most basic thing. Now remember, all of these things can move around. A lot of quadratic functions also look like this, like ax squared plus bx plus c. If you're going to do quadratic formula and things like that. Then you also have vertex form, which is a x minus h squared plus k. And so that form right there, that's vertex form because it tells you about the moving left, right, up, down, and all that. So you might not know it was called that, but it was. And parabolas are a nice U-shaped graph. All right, then you have polynomials, and actually a quadratic function is a polynomial also. It's one of them, but a lot of the polynomials, we end up calling them polynomials when you have something like, let's say, an x to the third problem, like ax to the third plus bx squared plus cx plus d, and a, b, c, d, those are constants, right, or coefficients, or integers. So, like a good old cubic function, it has twists and turns and it twists around and has, x-intercepts and things like that you're looking for. We've been dealing with a lot of those lately. All right, then you have rational functions. Your basic rational function is 1 over x. Remember, it has horizontal and vertical asymptotes. All right, and then it, usually looks something like this. It can look a lot of different ways, a lot of different transformations there. Then we have square and cube root functions. So let's say you have a square root function. Remember, the basic look of that is right here. It's starting at 0, 0, and it kind of curves up like part of a parabola. Then you have cube root functions. Remember those right there. They kind of snake over to the side. Okay, so these are all the things that you already know, all the different types of functions in your function families. All right, so now you're going to get exponential functions. There's two types of exponential functions. There's growth and there's decay. So if you have an exponential growth, it's going to look something like this. It's going to be starting very low, close to 0, and then rise up really fast. Okay, and usually the basic function goes to the point 0, 1. If you have exponential decay, then you're going to start up really high and fall back down towards 0. So that's decreasing versus the other one is increasing. And this is still going through 0, 1. All right, so notice on here, you're starting really low, you're increasing very fast. Here, you're decreasing very fast and then kind of bottoming out right there. Both of those graphs have a horizontal asymptote of y equals 0 right across here. That's your horizontal asymptote. Okay, now that horizontal asymptote can move if you go, up, down, left, and right, and stuff like that. So the horizontal asymptote will move if this graph is moved up or down. So let's go over the basics of an exponential function. So an exponential function looks like this. It has a number for a base. So let's say I'm going to just pick a number like 2, and it has x in the exponent. So that's the whole reason this is called an exponential function, because of that x in the exponent right there. And when you have something like decay, I'll go ahead and put like a 1/2, how about? So, and has an x in the exponent. So this right here is a growth problem because your base is bigger than 1. And this right here is a decay problem because your base is smaller than 1, in between 0 and 1. So growth, the basic function of exponential is y equals a to the x. All right, if a is bigger than 1, you have growth. If a is between 0 and 1, you have decay. And then later, we will do logarithmic later in this chapter. All right, so let's take a look at some more examples of exponential functions and move them around, and you also see how this shape is made. So, transformations. You know these things because you've done them before with your your other functions. Like let's say, for instance, you have something like, parentheses x minus 4 squared plus 2. And you know that that's a parabola, that this piece right here moves you to the right 4, and this part moves you up 2, things like that. Let's do it with like a square root function. And say you had negative square root x plus 1 and then minus 3 outside. So you know that this piece right here does a reflection over the x-axis. This part right here moves you left 1, and this part here moves you down 3. And then there's another piece that you can do if you have a number in front of here. All right, I don't know why I wanted to do my laser pointer, but I didn't quite get there. Anyway, a number right here would produce a stretch or a shrink. Remember, if that number is bigger than 1, like let's say you had a 5 here, that would be a stretch. If you had a number less than 1, like 1/2, that would be a shrink. Okay, so these transformations also apply to exponential functions. But what's more important with exponential functions is that it moves the asymptote as well. So if you had something like y equals, let's say, 2 to the x plus 4, then what would happen here, let's go ahead and put a plus 1 here also. So this would move your exponential function to the left 4 and move this one up 1. Okay, let's do another one. Let's say you had, for example, a 3, and then you had a 1/2 to the x minus 1, and that was all. All right, so let's look at what those do. This 3 is going to stretch your graph. This 1/2, now I didn't mention this before, but this 2 would mean you'd have a growth situation, and this 1/2 means you have a decay situation. All right, but this x minus 1 means you move to the right 1. And let's say someone also put like a minus in front of that. So that would imply you have a reflection over the x-axis. So those things should be familiar to you, and they basically work just like they did over here in your other functions that you already know about. Okay? All right, so let's see how some of these graphs are created. So we're just going to do it like a simple table here. A table of values like you do in Algebra 1. So I'm going to make an x and a y table, and then we're going to try to draw out some of those answers. Just sketch it real quick. All right, so y equals 2 to the x. So I'm going to put in 0 there, and then put some positives, and then put some negatives. Okay, maybe we could even go up to 4 over here. All right, so if I put 0, so 2 to the 0 would be 1. Anything to the 0 power is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the third is 8, and so forth. So this is 2, 4, and 8. So notice what's happening right here. As you go up the chain right here, you are multiplying by 2. So if you want to figure it out that way, 8 times 2, you know that next answer is going to be 16. Well, if you're going down the chain, you see you're dividing by 2. So if you want to figure it out that way, you could say, oh, 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. Or you also have the option of doing the negative exponents. Like, for instance, 2 to the negative 2. That really means 1 over 2 squared, which is 1/4. Or 2 to the negative 3. That really means 1 over 2 to the third, which is 1 over 8. Okay? All right. So when I try to graph these things, let's see, negative 3 and 1/8. So let's see, negative 3 and 1/8. So it's really close to the x-axis. Negative 2 and negative 1 and positive 1/4. So a little bit higher. Negative 1 and 1/2, a little bit higher. And then finally 0 and 1, right there. Then 1 and 2. And then it starts to rise up really fast. 2 goes all the way up to 4. 3 goes all the way up to 8. And finally 4 to 16, which I'm not going to show. So look at this green graph. So notice what's happening here. It's rising really fast, so it increases very sharply. As x increases, the y value increases with greater speed, in a way you could say. All right, and some more things. Let's see, this is 0, 1 right there. And also, do you notice an asymptote? There's a horizontal asymptote right here, because look at these answers that you have up here. None of them are negative. None of them are 0 or below 0. So your horizontal asymptote is y equals 0. So your domain is all real numbers, because you can put anything you want up in an exponent. So anything could go right here for this exponent. But when you get your range, the answers that get produced, all your answers are above 0, so 0 to infinity. And you can say or negative infinity to infinity here. Okay? All right, so that's just how you get the basic shape. It just produces this shape, this work, or this function that you have right here. All right, so let's do these. These have a little bit more of a, have some movements to them. So I'm going to base this on my last shape. Now, this is 4 to the x instead of 2 to the x. So it's not going to, you're not really going to notice unless we look at specifically at the points right there. But notice that this is up 2. So you're not going to notice that the points are a little bit different than the last graph. It's going to look pretty similar, but they are. So if you move your graph up 2, so your horizontal asymptote is going to move with you. It used to be at 0, so now it's going to be at 2. Because remember, your basic graph of a growth problem looks like this. It has a horizontal asymptote and it goes to the point 0, 1. All right, so there's your horizontal asymptote. It's now at y equals 2. That's going to be a big part of what you have to know about these functions. Now, this graph used to cross at 0, 1, so if you move that up 2 spaces, that's going to be 0, 3. So right there. And basically, you're just going to kind of copy the shape. It's a growth problem, so it looks like that. That's all we need to know. Okay, so growth. All right, this next one is also a growth. And so what that 3 does is every time you put a new x in here, the answer gets multiplied by 3. Like you're increasing it by multiplication, whereas before we've never done that in problems, right? So that's why it's growing so fast. So imagine like you said to your parents, you know, give me $1 on the first day of my allowance, and then the next week give me 3 times that, and then the next week give me 3 times that. So you'd be doing like 1, then 3, then 9, then 27, then what's 27 times 3? 91? No, 60 plus 20, 81, sorry. All right, and then, you know, keep going up. So it rises really fast. So what we also want to know about this is that it moves to the left 2 and down 4. So what's really going to affect your asymptote there and the look of your graph is the down 4. So that asymptote is not going to be at 0 anymore. It's going to be at 1, 2, 3, 4. It's going to be down here at negative 4. All right, and then we're just going to use that point. It used to be at 0, 1, like this guy up here. So if I'm at 0, 1 and I move myself left 2, so I move left 2 and then down 4, 1, 2, 3, 4, I'm right about here. So let me see if I can remember what that is. So right about here. So go ahead and make a mark of 2 here. All right, and so then I have my graph going up like that. All right, and you can also use Desmos, you know, type these things into Desmos to see a much clearer picture of these. All right, last couple things here. So let's do a couple that this one has a reflection to it. All right, so this reflection, this is another growth problem. So when you reflect it, you remember your main graph is going to go through 0, 1, you reflect it, it's going to come down to 0, negative 1. But your asymptote's not going to change because we didn't move up or down. So my asymptote is still at y equals 0, but now my graph is flipped down. It is going through 0, negative 1. So I'm going to have to turn it over, and it looks like that. Okay, so that caused a reflection over the x-axis. All right, and then we have this one example of a decay. All right, so imagine what's happening here. Let's try to plug in some numbers. So if I plug in 0, 1, 2, 3, and so forth. If I plug in 0 for my x, I get 1/2 to the 0, that's 1. Then I plug in 1. Well, 1/2 to the 1 power is 1/2. Then I plug in 2. 1/2 squared is 1/4. Then I plug in 3. 1/4 to the, 1/2 to the 3rd power is 1/8. All right, and so what's happening here as I go down, I'm always doing half of everything. Well, if I go back up, I'm always doubling everything, right? If you double 1/2, you get 1. If I double 1, I get 2, and so forth. And so that way, it's going, as I go to smaller x values, when my x values get negative, my graph actually increases. All right, so let's take a look at the picture. So I still have the asymptote at y equals 0. Nothing has changed that. A horizontal asymptote. All right, I still have the point 0, 1, but now as I go over to the right, the answers are getting smaller And if I went to the left, they would get larger. They would double in size. Okay, so that is a decay problem. Because what's happening is when you read it from left to right, you get to the graph and it falls down really fast. All right, so in summary, we have the basic equation of an exponential function with all the changes that could happen. All right, so this right here, remember that's going to be a stretch or a shrink. All right, if it's a negative, it causes a reflection. Okay, so based on that number right there, though, if a is bigger than positive a, but don't ignore the negative sign if there was one, but if a was bigger than 1, that's a stretch. If a is between 0 and 1, that's a shrink. Okay, this piece right here, if your b value is bigger than 1, that's going to indicate a growth problem. If your b value is between 0 and 1, a fraction like 2/3 or something, then it's going to indicate a decay. All right, this part up here is going to move you to the right or left. So that's your right or left motion. And this guy over here is going to move you up or down. And with that, that's going to be your asymptote. All right, that's going to change your asymptote as well. From y equals 0, it changes it to whatever that d value is, up or down. All right, and that's a general gist of exponential functions and graphing them. And I'll see you in class. Bye-bye.